Welcome back. During this class, we will study about a law which is called Pascal law. And in this law, we will see how the liquid pressure is exerted in case of liquids. During previous class, we have studied about liquid pressure, and then we are studying about Pascal's law. Basically, this law uh, explains about the pressure exerted in the liquid. So in 16th, the French scientist Blaise Pascal discovered a fact now known as Pascal's law. On the basis of this principle, the law, there are number of applications in our daily life, and it has made our life easier. And after this law, the hydraulic systems in machines came into existence. So that's why there are thousands of applications in our life where it has made our life more easier. Huge lifting of the load and heavy machinery these are, and ABS and other types of the latest brake system works on this principle. So this law is called Pascal's law, which explains the distribution of the pressure in case of the liquid. So if you look at here, it is when force is applied to confine a liquid, the change in pressure is transmitted equally to all parts of the fluid. So when we apply pressure in case of liquid, it is transmitted equally in all directions without any diminished. So here it is. A force applied to one section of an enclosed liquid at rest will transmit to the entire liquid with the same amount of force. Look, you are applying force at this point, but this force is exerted in all directions. Here, down, sideways, every side, the liquid pressure is transmitted. So this is the law, Pascal's law, that whenever we apply a force in case of the liquid at rest, this pressure is exerted equally in all directions. So keeping in mind, here it is, you perform an experiment, and what you do draw a bottle of water with arrow to illustrate the regular exerted pressure. Then draw a water bottle that you squeeze with the help of what happens to the pressure. And this is the type of the bottle, and you are applying pressure at the outer side of the bottle. You have drawn already arrows with the help of any marker. You see, when force is applied to a confined liquid, the change in pressure is transmitted equally to all directions. You will see pressing and releasing the bottle, the liquid pressure moves, water moves to all directions with along the arrow. This shows that this liquid pressure is exerted equally in all directions. So, applications of Pascal's law, hydraulic press. It works on principle, Pascal's principle. It consists of two cylinders having different cross-sectional areas filled with pistons of cross-section area A and B, small a and capital A. These are the two sizes of pistons, and we will see in the figure. The object to be compressed is placed over the piston of large cross-sectional area A. The pressure on piston of small area is small area, force per unit area. That is the pressure exerted on a small piston. And this P1 will be equal to P2 because the atmospheric pressure will be the same. So P2, that is basically F2 acting on a capital A basically. So if you look at F2A, capital A, and F1A, this is the pressure acting on a largest surface area piston, and this is the pressure acting on a smaller piston area. So we apply the smaller piston area, so it is transmitted equally and it reaches to the large piston area, large surface area of the piston, and by this way it works. So since the ratio of A or A is greater than 1, so hence the force F2 acts on the larger piston is greater than the force acting on the smaller piston. Hydraulic system works in this way are known as force multiplier Y, force multiplier Y. because we have applied less force on the smaller piston. This one, if you look at this one is a smaller piston, and the force which you are applying on this area, the area is basically small a, and this force is transmitted to the other side, and here the force acting is multiplied with the, if you look at here, arrow is single one, it means you are applying a single force, then it is converted, multiplied how many times? 2, 4, 6, 8, and 9 times. These are the example to understand how these machines works. Here you are applying less amount of the force, and it becomes multiplied to when it reaches to the larger area piston. So here is the place where you have to place any object which is to be lifted. This is the platform used to lift any object. If you look at this one is F1 force acting on piston 1. This one is F2 force acting on piston 2. So the area of piston 2 is larger, area of piston 1 is smaller. You apply a force, and this force becomes multiplier many times to increase the force from the larger surface area. As a result, it is helpful to the heavy to raise the heavy load or to do some useful work with the help of this application of the. So here it is. The force on the large piston is multiplied. Hydraulic press. So this was one of the application. If you see for the hydraulic press, first of all, you have to see the working. The brakes of some vehicle works on the principle working when the driver pushes down the pedal, the pressure on the oil increases due to the applied force. It turns the oil, transfer this pressure to the brakes of all the wheels. The brake shoe of the disc stops the wheels by frictional effect, which pressure is released from the pedal. The springs pull back the brake shoe and wheels against turns freely. So here it is. If you look at, this is the brake shoe, this is the piston, this one is called piston, this is the brake drum, and this one is the brake shoe, this one, and here is the place where the effect of the pressure will come with the help of this master cylinder. This is the place where a driver applies a force on the brake pedal. What happens with this force is transmitted with the help of the liquid to the master cylinder, and from master cylinder this pressure is exerted on the basis of liquid pressure in all direction. It reaches up to this piston, it reaches to the other piston, this one is also piston from the other side of the tire of car. So what happens when this pressure moves up to this place? These are the disc. They exert pressure on the disc, and the disc squeezes. As a result, the brake works and the car stops. And at the same time, if you release it, then again it relaxes, and with the relax, with these are the springs connected with the this portion, and these springs again detach and releases the pressure exerted on the brake shoe. So that's why it works, and the brakes works like this. So this is one of the applications of the liquid pressure, how it works. This works. It is explained in case of a brake system. Here it is the one point where it is called. These are connected with the master cylinder, and when a driver applies a force on its brake, then this force is transmitted equally in all direction. Means this pressure is transmitted equally in all direction uh, in accordance with Pascal's law. When this pressure reaches to the brake disc becomes squeezed, and the brakes are applied. At the same time, when it releases the pressure, there are the springs connected along the disc. So this spring again relaxes, and the grip of the brake shoe with the brake disc reduces, with the result the tires become free to move. By this way, this is one of the application of Pascal's law, how the brake system of the car depends. with this, our class ends. Hope you people have understood the basic principle of uh, liquid pressure. So here was one of the law which we have studied today, that is applications of Pascal's law. What are the applications of the Pascal's law? A very simplest concept. Whenever we apply a pressure in case of the liquids, this pressure is equally transmitted in all directions without any loss or without diminished. So we have calculated two by considering hydraulic press. We have considered two pistons, one with a smaller area, the other one is the large area. So we have seen that the pressure on the both sides will be the same. So comparing these two, we have calculated when and how this press works, and then we proceed. This one was P1, this one was P2. Both are the same, and the force becomes multiplier when it reaches and liquid reaches to the other side, because it is transmitted equally in all directions. So that's why we have calculated the force acting on piston B, and then we calculated that it becomes work becomes more easier. Then this is hydraulic brake system, and we have seen how the hydraulic brake system works. It works with the principle of Pascal's law, where the liquid pressure is transmitted equally in all direction, and then on the basis of this principle, the brake system works. With this, I thank you very much for your